Hello everyone, this is the solution for problem 1 in homework 4. Firstly, we know that the random variable x and the random variable x satisfies the function of g, and the gx and the formula of gx is 2 when x smaller than 0 and 0 when x larger than 0 smaller than 1 and negative x plus 1 when x is larger and equal to 1 and smaller and equal to 2 and is negative 1 when x is larger than 2. Then we draw the sketch of the fx or gx. It should be like when x is smaller than 0, it should be 2, and when x is in the interval 0 to 1, it should be 0. And when y is in the interval 1 to 2, it should be linear. So this is negative 1. And when when x is larger than 2, it should be negative 1, a constant negative 1. And therefore, we already draw the sketch for the gx. Then we can formulate the CDF of variable y. So firstly, when y is larger than 2, we know that y is always smaller than 2 when y equals to gx. So the CDF for fyy should be 1. Second, if y is larger than 0 and smaller than 2, it should be this part in the sketch, and the probability or the CDF of y, it should be the probability of y is smaller than y, and it should be it should be the probability of variable x is larger than 0, and so that it should be y minus the CDF of fix0 when y is larger than negative 1 and smaller than 0. It should be this part in the interval, and it should be it is mapped on this part of x. So because it is linear, it should be formulated like equal to the probability of negative x plus 1 is smaller than y, and it should be the probability of a capital X is larger than 1 minus y, and if we represent it with the CDF of variable x, it should be 1 minus fx 1 minus y. So for the large part, for the last part, if y is smaller than negative 1, so actually y is in the interval negative 1 to 2. Therefore, y will never smaller than negative 1. So the CDF of fyy when y smaller than negative 1 is equal to 0. So in general, the CDF for variable y is 1 when y larger than 2, 1 minus fx0 when y larger than 0 and smaller than 2, and is 1 minus fx 1 minus y when y is larger than negative 1 and smaller than 0, and is 0 when y is smaller than negative 1. So if we represent it with the step function, it can be formulated with only one function. It should be y minus 2, this is this part, plus y minus fx0 u y minus uy minus uy minus 2, and this is this part, and plus 1 minus fx 1 minus y u y plus 1 minus uy, and this is the third part, and in the last part, no last part though. In the last part, it is equal to 0, and this part can be omitted. Then we compute the PDF using this for this representation of the CDF. So because fyy is equal to the partial of fyy corresponding to y, so that it should be delta y minus 2 plus delta y minus delta y minus 2 plus y minus fx y minus y delta y plus 1 minus delta y, and it should be y equals -1. It should be this part, and it's y minus fx 2 delta y plus 1. Actually, delta y plus 1 is 2, but I want to write like this. And if y is larger than 0 and smaller than -1, it should be fx 1 minus y, and y equals to 0. It should be y minus fx 0 plus, so it should be -1 plus fx y minus y, and it should be fx 1 minus 1 y is 0, right? Oh, this is 1. It should be fx 1 minus fx 0 times delta y, and y when y equals to 2, it should be fx 0 delta y minus 2, and otherwise it should be 0. Then we draw the sketch of the PDF and the CDF. For the CDF, this is fyy, firstly, when y is smaller than -1, it should be 0. It should be 0, and y is between 0 and -1 and 0. It should be 1 1 minus this part, and when y equals to 0 is 1. This is 1 minus fx 1, and this is 1 minus fx 2 1, and this is look like this. When y is between 0 and 2, it is a constant. The constant is 1 minus fx0, and this is 1 minus fx0, like this. At last, it is 1. Y is larger than 2, and this is 1. So the CDF should look like this. Then for the PDF, so when y equal to -1, it is impulse function. The impulse, the area for the impulse is 1 minus fx2. Right. So when is between this, it should be fx 1 minus 1, and the scratch of fx is look like this. And then the function of this should be like this. And this is fx0. Then it is 0. Then for 0, this is also an impulse function, and the area of the impulse is fx1 minus fx0, the area. Then at last, when y equals 2, it is also an impulse function, and the area of impulse is fx0. So now we solve this problem and draw the scratch of CDF and PDF.